Okay, looking at assignment number 4. The last time we were together, we talked in detail about the first, I want to say 8 problems here through 612. These go along with the information from, if you would, part 1 of our lecture. And we did go through each one of these. So I'm not going to repeat that information. The ones where I wanted to go over in detail is going to be the last 4 that you have here, which are going to be the relative velocity graphical method. Okay. So starting on page 162 in your book, we will find our first problem, which is problem 621. It says for the reciprocating saw down here, right here, use the relative velocity method to graphically determine the linear velocity of the blade as the crank wheel rotates counterclockwise at 1500 RPMs. So what you're going to do is you are going to represent this as a slider crank mechanism. Do not worry about the blade being further out. All you want to do is, I'm going to zoom in here. You're going to draw just a radius, the connecting rod, and just a slider right here. That's it. Okay. And the slider is going to go back and forth horizontally. Don't worry about the blade sticking out further. Okay. That's not necessary because all you want to know is you want to know what is the linear velocity of that blade. Okay. So it's a slider crank mechanism. This is going to be like the first example we did. Actually, it's going to be like 620. It's going to be just like 620, just oriented a little bit differently. Okay. We did this as the second to last example in our handout. Okay. It was a slider crank mechanism. So that's going to be your reciprocating saw. Same exact process. Okay. The next one that you have is going to be 623 for the shearing mechanism that we see here. Okay. So we have a blade going up and down. This is going to be your slider. This is your crank right here. Determine the relative velocity, or using the relative velocity method, determine the linear velocity of the blade as the crank rotates at 100 RPMs clockwise, this way, clockwise. Okay, so the crank is going around this way, and you want to know the linear velocity of that blade at this moment. So this is another slider crank mechanism, except it is oriented horizontally. I'm sorry, vertically, where the ones we were looking at were horizontal. Only difference there. Okay. Otherwise, the process is the same. So this is again like the second to last problem that we did in our handout. Okay. Let me look back here. So that's 21, 23. Our next one is 28. Okay, 28. 28, we look here, the device in figure 627, we just did this problem, okay? We're going to use that same diagram for the configuration shown, and then up at the top here it says, use the relative velocity method to graphically determine the angular velocity of the water bath, same problem, as the crank is driven clockwise this time, not counterclockwise, at 75 RPMs. So very same problem, same dimensions, same base diagram. So all you gotta do is copy and paste this diagram, but this time we're actually going to rotate clockwise at 75 RPM. So the direction of the velocity of B is going to be different, okay? The direction of VC is going to be different, okay? So, but the process, the exact same problem is what you'll follow that we did in that last problem that we did in our handout, okay? And then the very last problem we're going to do is going to be 631. This is a hand-operated shear down in this illustration right here. Use the relative velocity method to graphically determine the angular velocity of the handle this time. So the handle is right here. We want to know what is this? It will be W2, okay, because that's our input, kind of doing a backwards problem here. When the blade is cutting through a material at a rate of 3 millimeters per second. So if it's cutting through, it's going down, right? Right? That's how it's got to cut through. It's not going up, it's cutting through, so it's going down at 3 millimeters per second. So if this is going down at 3 millimeters per second, what is the rotational speed or the angular velocity of that handle? Okay. You do not need to determine the linear velocity of point X out here. Don't do that. Okay. And I did remove that also in the instructions on assignment 4. So if we go back underneath here, you're going to notice solve for W2 only, not X. Okay. Okay. So these last 4 problems are an illustration or an application of the things that we talked about today. Now, I wanted to let you know that this Friday, we go back underneath here. This Friday is that work time. But as I was looking, I'm like, you know what? On Friday, I am going to go over problem 621. I'm going to start from the beginning, go through the end, set it up. So if you wanted to be there for that, come to class or come to our Zoom meeting on Friday. I will record it, so it'll be out there for you. So if you can't make it, I will be recording it, but I'll be going over this one during our time together. The other one I'm going to go over is going to be the last one here. Okay. This is kind of that backwards one where we're starting at the output, if you would, and going back to the input. So you're going to find it's going to be very similar, but I will do this one on Friday as well. So if you wanted to come in and be there live for that, you're welcome to. And otherwise, like I said, I'll do the recording for it. Okay. Any questions about that and this assignment? All right. If not, then go back over here. I will stop the recording